Good morning all. Today we will be discussing about the diode clipper circuits. Clipper is a wave shaping circuit. It is used to remove a part of the signal either in the positive side or negative side without distorting the remaining part of the signal. The diode circuit is otherwise called as slicers or limiters. Based upon the output what we get, the clipper circuit can be given as positive clipper and negative clipper. And also the positive clipper can be either series connection or shunt connection. The diode, how we are connecting it in the circuit, will classify the positive clipper as series positive clipper and shunt positive clipper. So before going for the circuit, we will understand how a diode works. As given here, the diode when forward biased is replaced by the short circuit. That is, when a diode is forward biased. What is meaning of forward biasing? When anode is more positive than the cathode, the diode is said to be forward biased. So when a diode is forward biased, this can be replaced by means of a short circuit. So this is the case of the ideal diode. So this is called as short circuit. When the diode is reverse biased, that is when anode is less positive than cathode, the diode can be replaced by an open circuit. The diode can be replaced by the. So this forms the basics for getting the output of the clipper circuit. So when the diode is forward biased, it is replaced by a short circuit, and when the diode is reverse biased, it is replaced by the open circuit. This is the case of an ideal diode. So now we will go for the first circuit, which is nothing but positive series clipper. So as shown in the circuit diagram, we can see that the diode is connected in series with the load resistance. So here, when we take that the input is a sine wave with amplitude, peak value of Vm. So what will happen to the circuit when the input is in the positive half cycle? So during the positive half cycle, our cathode will be positive, the cathode terminal will be positive compared to the anode terminal. So the diode is reverse biased and the circuit will be replaced in this form. So the diode, the D, is replaced by an open circuit. Since there is an open circuit, there will be no current flow through the circuit, and hence V0 will be equal to 0. So during the negative half cycle, anode is positive and cathode is negative. So the anode is more positive when compared to the cathode, and hence the diode is forward biased. So in the case of forward biasing, the diode is replaced by a short circuit. So here, when we write a KCL, when we write a KVL, we can write that V0 will be equal to Vi. So the case is when input is positive cycle, V0 is equal to 0 volt, and when input is in negative cycle, V0 is equal to Vi. So this output will be, the output of the circuit will be 0 during the positive half cycle, and the V0 will be equal to Vi during the negative half cycle. So this is my minus Vm. So this circuit clips the positive half part of the input waveform. Hence it is called as the positive clipper. So the same circuit can be also redrawn with the diode in parallel with the load. So in that case, the circuit is, so what will be the operation of the circuit during the positive and negative half cycle? So during the positive half cycle, that is when the anode is more positive than the cathode, so the diode is closed circuit. So now during positive half cycle, the circuit becomes, so let us consider the other version of the positive clipper. Here the diode is connected in parallel to the load resistance. So during the positive half cycle, anode is positive when compared to the cathode. So anode is positive when compared to the cathode, and the diode can be replaced by a short circuit. So here the maximum current will be flowing through the diode, and hence this path, and hence the V0 will be equal to 0 volt. So during the negative half cycle, so the anode is negative when compared to the cathode, and hence the circuit acts as an open circuit. The diode acts as an open circuit. Hence the maximum current will be flowing through the output point, and hence V0 will be equal to VA. So in this case also we have got the same output as this. So the positive clipper can be given either in this way or it can be drawn in this way. In both the circuits, the input part, the positive half of the input part is clipped and we get the output only for the negative half cycle. So this is the positive clipper, this is a shunt, a series positive clipper, and this is the shunt positive clipper. So now we will be going for the negative clipper circuit. So next we will be discussing about the negative series clipper. So the circuit is given here. So D is the diode which is connected in series with the resistor R. Here the input is VA and the output is V0. So during the positive half cycle, my anode will be positive when compared to the cathode. So the diode is short circuited. So the circuit is getting replaced in this form. So in this case, we can see that the diode is short circuited and hence the complete current will be getting at the positive half cycle. So here we can say that V0 will be equal to VI. So during the negative half cycle, the diode is open circuited and hence it is in the circuit it is open circuited and the resulting circuit will be this. So here there is no current through the diode and hence the circuit will not conduct and hence V0 will be equal to 0. So we can consolidate the result as when Vi is positive, V0 is equal to Vi, and when Vi is negative, V0 is equal to 0 volt. So if the input is given in this form, so the output will be only the positive half. So the negative, for the negative half, we will be getting the output as 0. So this is a series clipper. So here the negative series clipper clips the negative half and it passes or allows only the positive part of the output to positive part of the input at the output side. The same circuit can be explained by replacing the diode in the parallel path. So in that case, the diode can be, the circuit can be simplified as, so this is my load resistance RL. So here this is the R diode. So during the positive half cycle of my input signal, so the diode is reverse biased. So the diode is during positive half cycle, D is reverse biased and hence it is replaced by open circuit. So the circuit gets changed to this form. So now what happens is the complete current will be flowing through the load resistor R. So during the positive half cycle, so the current will be following this path. So here when we write KVL, we can write V0 will be equal to Vi. So during the negative half cycle, so the diode is replaced by a short circuit. So the diode is replaced by the short circuit. So the current will be flowing through this path and hence there will be no current through the RL resistor. Hence V0 will be equal to 0. So this gives me the same output as in the series case. So during the positive half cycle, the current will be flowing through the RL, whereas during the negative half cycle, the current will be flowing through the short circuited path. So the current through the RL resistor is 0 and hence V0 is equal to 0. So this gives the output of a series or shunt negative clipper. Thank you.